Hi, I'm Sherban and today I'll show you how to secure your web app. The first thing that I would want to talk about is the concept behind Spring Security, or the way in which it works. Basically, once you enable Spring Security, which is just a library in the Spring ecosystem, it will apply a set of filters, a set of built-in filters to your web app. These filters are a layer on top of the controllers, so they actually can decide if a controller should be called or not, or if a request should reach a controller or not. That's the better way of putting it. And in the case of Spring Security, they do this by checking the currently logged in user, if any user is logged in, if he has a specific role or authority, and you could do basically anything in there. This filter group or filter chain is applied by default. You don't have to do that much. You just have to tell Spring Security on which URLs to do the checks, what type of checks, and so on. We will see an example later. And apart from this filter concept, there is also a more fine-grained concept that you can apply to your services. So you can do a method level security check. Basically, you can annotate a method or a set of methods from your services with a pre-authorized annotation. And basically, that annotation instructs Spring to perform a role check or a security check in general. Usually, it's used for roles before allowing your controller to invoke the service. How this works basically in the same way in which a transactional annotation works. So just as a small recap, basically the transactional annotation and also these pre-authorized annotations create proxies. So your service implementation is in the middle, and then on top you get a kind of a shell, which is the proxy. And this proxy intercepts all the incoming method requests from outside before they reach the core, which is your implementation. And the proxy can decide, well, in case of the transaction annotation, the proxy just does some extra work, like opening a database transaction or doing a commit. In the case of this pre-authorized, it actually performs a check. If the user has, for example, a role, then it allows the call to go to your real service and the work to be performed. And if the user does not have such the required roles, then an error is thrown and it results in a response, usually, which is a forbidden or an unauthorized response. It depends. Okay, let's talk a little about what it means to be logged in, right? So I mentioned that typically both the filters and also these pre-authorized checks check if the current user or the currently logged in user has a role or exists in general. Basically, your app has to have a mechanism for logging in, or a mechanism for the users to log in. And there are several mechanisms available, but I'll talk about two in particular, which are the most simple ones. There is the basic. For HTTP basic, there is a specialized header called authorization. And in that authorization header, in a special format, your username and password is located. And that header is put on every request. So if you browse, for example, a website which uses this HTTP basic authentication, then for each click you do, your username and password is sent by the browser automatically once. As you can imagine, this is pretty insecure because your password is always going around. Another option is the one that we will use. It's called form-based, and it limits the amount of traffic which is done with your username and password. Basically, the flow is the following. Let's say that you try to access a protected resource. The server checks if you're logged in. If not, then it redirects you to the login page. And here it's a specific login page, a HTML page in which you have to enter your username and password. And it usually has a submit or a login button. Once you click the login button, a request is done to the server. It's typically a post request which contains your username and password. And that's really the only time you have to do this once you log in. So the only time when your username and password actually leaves your client. And the server then checks if the password given is correct for that given username. We'll see later what correct means, because actually it's not just the equals check typically. If it's fine, then you get redirected back to your original requested source. And if there is a failure, of course, you get the error message. On this step, on step number 4 on this diagram, there is something else happening. The server sets a cookie. What is a cookie? A cookie is just, again, a set of key value pairs, or basically in this case it's just one key value pair. It's the name of the cookie and then the value, and they are set through headers. So the server responds with a specific header, and the client then knows, okay, I have to store this header, and on all subsequent requests I send this header back to the server. So basically it's similar in this way, that through a header some data is always transmitted to the server, but in this case it's not the username and password, it's instead like a ID, usually a very long ID, a UUID or a GUID, which does not contain your username and password, but points toward the information that, okay, you're successfully logged in once at I don't know what time, and then for the next I don't know how many minutes you're still logged in. So then if somebody manages to steal this cookie value, for example, they don't have complete control over your account because they don't know your password. They can just do the small set of actions that are allowed in this app, right? You will see that generally in security, or in application security, it's preferred to lose some kind of generated secret like a cookie than to lose really the password, right? And that actually segues pretty nice into the next concept. So I mentioned that when you log in, the server does not typically just check with equals if the password stored in the database, let's say, is equal to the ones that you provided. Why? Because if you have vulnerabilities, if you really store your users' passwords in plain, you risk that somebody steals the passwords themselves. And we know that pretty frequently users reuse their passwords on multiple websites. So if there is a hack on, I don't know what, gaming website, for example, some users might get their bank accounts hacked, for example, because they use the same password. That's why also banks usually don't let you set a password but a PIN, because very few websites right now use PINs. Okay, so then what's the solution to this? Well, the solution is to not store the password, but a hashed version of the password. A hash is just a function which transforms a string, the password in our example, into another representation, let's say, but a representation which is not cannot be transformed back to the original password. So usually hashes have several properties. One of them is that they don't have collisions, or very, very infrequent collisions, for password hashes at least. Collision is when you have two different passwords, but they hash to the same value. So once you apply this function, they have the same output. That would be, of course, bad, because somebody could log into your account by inputting a wrong password. If there is a collision, it would work. Okay, so how does a login work in this case? Well, we have the username and the password in the database, but the password is not stored in plain, but is hashed, is transformed. And then when you try to log in, we search for your password in the database based on your username, and we obtain the hashed version of this password. We take the password that you gave us, we also hash it and compare the hashed versions. So we do an equals check, but not on the passwords themselves, but on the hashed versions. And that is because in the database we don't have the real password value, we have the hashed value. And okay, of course, if the hashes are the same, then the user is authenticated. Okay, so this is a security measure to not store plain passwords in the database. Okay, enough talking. Let's try to configure this and get it up and running. So the first thing that we'll have to do is I'll have to enable the dependency that I disabled really in the first week, which is the Spring Security dependency. Okay, so this automatically adds in our libraries, the security library. Then I need to create a configuration. So I create a configuration package and I create a new security configuration class. I annotate it with the configuration annotation. This is similar to a component. It's something that is instantiated automatically by Spring, but it's used to modify the way in which Spring works typically. Then I use the enable web security annotation. Okay, and I want to extend a built-in class from Spring, which is this web security configure adapter. This is a built-in class that we can use to modify the way in which a default web configuration or web security configuration works. And there are two parts that we want to do. One part is we want to tell Spring where to find the users, and the other part is that we want to tell Spring which URLs to secure and how. Let's do first the HTTP configuration. So this one, we tell Spring which URLs to secure. We will say that any calls on the API login, which will be a login URL, can be anonymous, so anybody can access them. And then any other request should be authenticated. That's enough for now. Then we tell it that it should be a form-based login. And here we can say, okay, the parameter in which we will receive the username should be called username, and the parameter on which we receive the password should be called password. The URL on which we expect these two to arrive should be called API login. And I guess that's enough. Okay, and we of course want also a logout, and the URL should be API logout. Right, so these are in the end kind of API methods. Okay, good. Let's start the app just to see what happens with this setup. Okay, so if I go on localhost 8080, I am redirected to a default login page. Okay, and here I can actually log in just to see if it works with the password that is written here in the command in the terminal, right? So in the terminal, if I don't configure a user store, Spring automatically creates a user called user and with this password written here, right? So this will change each time I restart the server. Okay, and actually it works. Of course, I have nothing here in this path. But for example, I could try access the topics and it seems to work, right? Okay, good. Now the next thing that we want to do is we want to actually get the users from the database, right? So not use this auto-generated kind of user, but to get the users from the database. Okay, so how do we do this? Well, we have to go and change our migration. I'm still changing the initial migration because the structure is not yet final. Once we have a first kind of rough version, then we will create further migrations. I'll create a new table called user. have a username, which is I guess an varchar of 64, it's enough. This is the primary key. And apart from this, it will have a password. Of course, it will be hashed. And this will be an varchar of 500 something. And this for sure is not null. It has to have, each user has to have a password. And yes, actually I'll move this more downwards because I don't want to pollute our domain tables with this kind of technical table. So in here I will add the teacher ID, and this could be null if this is a foreign key to the teacher table, just in the case that this user is a teacher. And this will be a int, and it references teacher on ID and on delete cascade, right? So it's the same as the other one. Okay, if we restart, this table should be created. Hopefully user is not really a keyword in H2. Okay, so looks like this table was created, but I also want to create some mock data for this. So for this first guy, I will insert also a user. Insert into user, username, password, values, and here, and also teacher ID. So the username will be test, or actually let's call him Wolfie. Easy to remember. The password will see, and then the teacher ID is 1, right? So 1 is the ID of the first teacher. Okay, we need now to create a hashed password by hand. So for this, I'll use this website. This bcrypt is the hashing algorithm that we'll use, and this is the password I want to hash. So example 123, and this is the result. So this is the hash of this password. Right, it's pretty different. Okay, good. Let's restart to see if we wrote this insert correctly. I expect it. Yes. Yes, okay. Good. And now the next thing that we have to do is we have to tell Spring Security, okay, take your users from here and also give the teacher role for the ones that have really teachers. So to do this, the first thing that I want to do is I want to create a user entity. So it will be an entity, it will be a data object, have a username, which is the ID, and in this case is not auto-generated, and it will have a password. And lastly, it will have a reference to a teacher, maybe. And the join column is named teacher ID. Okay. And I'll create also a repository, a user repository. And this will, of course, extend the CRUD repository. Oh, no, sorry, it will be for users. And the second one, as I mentioned, in a previous video is the type of the key of the ID. In this case is the username, so it's a string. Okay, good. Then we will have to create a service, call it the database user service, which has to implement the user details service from Spring. This is a kind of a well-known interface that we have to implement, which loads the user details for a user given by username, right? So in this should be a service, and we'll have a required Dart constructor. We will inject the user repository, and we'll have to construct these user details for a given user. So this is the interface, of course, but it has a kind of a standard implementation in Spring. So what we will do, we will say repository find by ID. The ID in our case is the username. And then we map. And we will have to see how we write this mapping. And then if not, then we throw a new username not found exception. Let's see what constructors it has. Well, it has a constructor with one parameter. So the requested user was not found. Right, so I wrote a small lambda here, which throws the exception like this when we don't find the user. Okay, and then lastly, we will write a small static method which creates a user details object from our user object. And here there is a small problem because we named our class user, and the class from Spring which implements this user details is also called user. They both have the same name, right? So we'll have to use the fully qualified name. Or we could name it maybe better our user. So we will get a username, password, and we have a third parameter in the constructor. Right, so it's username, password, and a set of authorities. So we will create a list. It can be empty initially, but actually we want to see if the user is a teacher. So if there is this relation, then we say that it's a teacher, otherwise it's a student. And well, this list has to be of a granted authority type. So we have to create this kind of granted authority based on these strings, or on this string, right? So then this is a list of authorities, and it's basically just one authority, which is based on this string spec. It's really important that it starts with role underscore, and I would suggest that it has to be uppercase. Okay, so then here in the map, I just say this map user. Or not this, actually, because I made it static. I use the class name. If it was not static, I could use this. Okay, so then this should load the user. And now we need to connect this service to the Spring Security. So we'll do it here. And I have to override another configure method. So I'll say auth dot user detail service. And here I have to inject first my database user service. Okay, so I injected it and now I just set it here. And I will set the password encoder to use bcrypt. And that's it, basically. So this is again important such that the algorithm that is used to hash the password really fits the password that we created in the mock data. So we restart the app. And now you can see that actually we don't get auto-generated password anymore. And we can check. So if I try to log in, the username was test and the password is example123. Bad credentials. Okay, let's see. The user is not test. Wolfie. Example 123. And I could log in and it's successful. Okay, so before we go on, we need to adjust slightly our configuration. Spring Security has built in a security option which prevents a specific type of attack. It's called the cross-site request forgery attack. And in our case, we want to disable this. So we have to do and CSRF disable, just for now at least. So this attack is still, or sometimes is still used today, but in our case it's not that important. It would complicate from the start the way in which we make the requests and so on, and right now I think it's not really useful. Okay, so we can restart the server. This should be taken into consideration immediately. And now the next thing that I want to show you is how to make such requests or to adjust your Postman requests such that you can still do them even after we configure this login stuff. Okay, so if I open a previous request, like for example this list topics request, and I try to make a call, I don't get my JSON anymore, I get this HTML, right? I can press this preview button and I'll see that it's really the login page, right? So I want to not have this and instead have something else, or instead actually perform the login first. And I'll create a new request for this. I'll call it login. And it will be a post. It will be on API login. And here in the body, it will be a form encoded body, which I put the username, this Wolfie, and the password is example123. Immediately make this request. And well, you notice that I got already the topic is because Spring remembered what I tried to access the last time. Right? But now if I, for example, make this request or any other request, it works just because Postman remembers the cookies that I set. So that's all for today. In the next video, I'll show you how to perform more fine-grained authorization and how to retrieve the current user such that we, for example, just show the topics of the current teacher when needed. Okay, thanks a lot and see you in the next video.